Welcome to Anandaram Pro Academy. I am a physics teacher. My name is Devaprati Mohanto, and I am going to teach you your first lesson, first chapter, physical world. So look, this chapter is nothing but to know about some laws and some scope of physics. But there are no questions coming from this chapter, so don't worry. Okay. So before that, so I'm going to ask you. I want to ask you some question. Do you have any curiosity about the night sky? Do you have the curiosity about the volcanoes? Do you have the curiosity how days and night happen? Do you have the curiosity about the eclipse? Do you have the curiosity about the stars, about the planet, about the asteroids, about the machines, your phone, your computer, TV you watch? These all are based on the principle of physics or some technology which are based on the physics. So look, even from morning to night, having a cup of tea to have dinner, everywhere physics is related. Forming a star, even forming a star, standing on the earth, connection between the two stars, connection between the planets, sunshine, these are all the physical phenomena. So these physical phenomena are related to, if they are related to physics, that means physics is the nature. Right? Physics is the nature. All the natural physical phenomena are abide by the laws of physics. So there are four sciences, natural sciences we are going to deal with. One is the physical science, which is physics. Another is mathematical science, which is mathematics, chemical science, which is chemistry, and biological science, which is biology. So actually we can feel the physics, we can feel the physical situation, physical phenomenon, right? When we are talking with a friends, when we are watching the nature, when we take the heat from the sunshine, these are all feelings we get are from the physics. So it is a very beautiful and interesting subject. Very beautiful. So from taking brush in the morning, having class in your school, having dinner with your family, these are all the related to the physics or physical some laws. When boiling a cup of tea, okay, switching your bulb, switching your fan, switching your mobile, your laptop, your TV, these are all technology based on the physics. So there are some section, there are actually basically two sections of physics. One is unification and that is reduction. So what happened in unification? Unification means to make unified. Suppose you have you know some laws, another knows another laws. So both two laws have the same base. So you just unify the two laws and get one. That is the unification. So we have dealing with many such like the laws. So conservation of energy, conservation of momentum, conservation of mass, conservation of parity. These things, parity, momentum, mass, we are dealing with later actually. So another part is reduction. What happened to reduction? Suppose you have a complex situation. You have a complex situation. Complex situation means you have a problem which give different step to achieve the solution, which have many different steps, and we have to get out the solution. Then that you have to calculate each step, then you get the solution. That is, you reduce the whole problem in a subsection. That is called a reduction. So there are many scopes in physics. Some subdiscipline are there. Main two basic subdiscipline are the small scale of physics and large scale. There are two scale, small scale and large scale. What are the large scale? What are the small scales? So basically, large scale are those who actually we can imagine, or we can feel, we can see by our naked eyes. These are the large, like the physics of planets, physics of mechanics, physics of optics, physics of electromagnetism. These are all in large scale. And in small case, suppose physics of electron, physics of proton, physics of neutron, physics of elementary particle, physics of photon, gluon, boson. These are the small scale. Large scale means we are dealing with macroscopic way, and small scale means we are dealing with microscopic way. So in this modern era, this large scale term as classical physics and small scale term as quantum physics or modern physics. In classical physics, main classical physics is based on the Newton's law. Newton's first law, Newton's second law, Newton's third law. Laws of inertia, you got in class 9 and class 10, right? Laws of inertia, force, and third laws of motion, Newton's third law, action and reaction. Then laws of gravitation, most important, laws of gravitation. Then optics, then electromagnetism or electricity and magnetism. In electricity, we got the Coulomb's law, we got the Ampere's law, Oersted law, Maxwell's law or Maxwell's equation. These are all in electromagnetism. So in one of the most interesting thing in classical mechanics or classical physics is the astrophysics. One of the best and imaginative and beautiful physics, that is the astrophysics. So forming a star from interstellar medium and the end as a black hole, these are all the astrophysics. Forming of earth, forming of sun, any star, cluster, group, and then die as a dwarf planet, and then die as a neutron star, and die as a black hole, and or blast as supernova. Is the most interesting phenomenon in astrophysics. Back to I think in 2017, you got the first image of black hole, right? 2017 or 2018, maybe fluctuating the year. You got the first image of black hole. So what is black hole? There's nothing inside there. There actually singularity. There is nothing. Complete void. That is the black hole. In a simple sentence, if there is a singularity, then there is a black hole. Singularity means, what is singularity? if you know a little bit about the mathematics, then if something is divided by 0, then it becomes infinity, right? It becomes infinity. That is meaningless. Infinity means that is no value. So this infinity we term in astrophysics as singularity. Singularity. For a black hole, it has tremendous strong, very strong gravitational field. So even light cannot escape from a black hole. So that's why the hole is black. So when we are talking about the light, some interesting phenomenon happening to the light. Light has dual nature. One is particle nature and another is wave nature. So how it behaves as a particle nature and wave nature? So first example of particle nature is the black hole. Since light cannot escape from a black hole, that means light must be a particle, because gravitation, we are going to talk about the gravitation later. So in case of gravitation or in case of gravitational field, only that particular assigning gravitational field of gravitation which have masses. Okay, so what is a light particle? Light particles are the photon. Light particles are the photon. Photons are called the light particles. In rest, that is when I am standing here, I am actually at rest. That means if I am a photon, in rest, my mass is 0. That means the mass of photon in rest is 0. When it comes to move, it has mass. That is another part of physics called the relativistic physics. Okay, you are going to get this again in class 12, relativistic physics or relativistic mechanics. Okay, so here light behaves as a particle, and when you get the sunshine, in that case light behaves as wave, electromagnetic wave. So light has two nature. One is wave nature, another is particle nature. And these are all about the classical or the large scale. And we are going to tell about some microscopic world or microscopic physics. So in microscopic physics, actually we call as quantum physics. In quantum physics, we are going to deal with elementary particle. That is the particle, electrons, protons, neutrons, gluons, photons, even photons, bosons, etc. All the elementary particles. We are going to calculate the interaction of those elementary particles. So all the physics related to this small scale or microscopic particles, this physics is called the quantum physics. So now quantum physics is one of the most popular physics for research. Okay, so when you going to do research about the physics, I think at your time you get more data on quantum physics, more phenomena related to quantum physics. Very exciting level. Okay, so now let's talk about the technology. How technology develop based on the physics or based on the natural science. So now I am what I am doing, I am doing a video, okay? I am recording a video in front of a mobile for you. So what I am going to do next? I am going to next then I think it has a more memory for me, so I am going to compress it. Okay. Then I am going to upload it in YouTube, and I am going to give you the link of YouTube to watch this video. Okay, look at this chronology. What I am going to do? Recording the video. That means I am using the technology to record the video. Okay, this technology record my sound, record my image. Okay, then I transferred it without anywhere wirelessly. We're going to upload it to the server, then we got it from the server. So these are all technology based on what? Based on physics or some natural science. And actually I think you all have the laptops or computer or mobile. You know about the memory, right? You know about the memory. Some mobile has 128 GB memory, some mobile has 64 GB memory, some laptop has 500 GB memory, 1 GB memory. Okay, we are all going to talk about this. So what is this memory? Okay, how it is actually a form or how it is actually generated? What is actually what is the base on this? These are all the solid state. These are all the solid state physics. That is, this technology based on the one part of the physics, that is the solid state. Okay. First of all, when I bought the laptop, that laptop has the memory of 500 GB, that is called hard drive memory, HDD. Now you have SSD, that is solid state drive. That means that technology is developed to this technology based on what? Physics. So somehow when you develop a technology, you have to improve the science. Or when science is developed or when science is improved, the technology is further developed. So science and technology are related to each other. They are not apart from each other. When you have technology, you must have science. Or when you have science, you can develop a technology. Right? So science is the truth. Science is the truth. So that's why actually there is a conflict between the God and science. Maybe both are going the same direction, or maybe they are both the same. So physics is the most interesting subject along with the others. I am not telling that chemistry, biology, mathematics are not. They are also very interesting. So along with those subjects, physics is one of the most beautiful, most interesting, most exciting subject. Now, let's talk about some fundamental force. There are basically four fundamental forces. One is, number one, gravitational force. Number two, electromagnetic force. Number 3, strong nuclear force. And number 4, weak nuclear force. These are fundamental forces of nature. Physicists are trying to unify these 4 forces. They are trying to unify these 4 forces, and somehow they are able to unify electromagnetic force and weak nuclear force. So we are called as electro-weak force. Electro-weak force. These are unification of electromagnetic force and weak nuclear force. But since these three forces are all going to deal with the quantum level, but this thing is going to on the classical level. So physicists are not even unified all these 4 forces yet. I think in when quantum gravity will discover, when finally foolproof discovered, then I think all 4 forces will be unified. Grand unified theory will be developed. So what is gravitational force and what is electromagnetic force, strong force, weak force? The interesting thing about the gravitational force is that we are actually connected to each other by the gravitational force. You are sitting at home connected to me. Someone in the space connected to me. Jupiter is also connected to me. Sun is also connected to me. Proxima Centauri is also connected to me. Vega is also connected to me. All are connected. Because how connected? Gravitational force has the range of infinity. Gravitational force has the range of infinity. It has the infinite range. So when the range is infinity, we are all connected. But what is the main element to be connected by the gravitational force? That is the mass. You must have mass. A massless thing, a massless object are not connected by the gravitational force. What is the carrier of the force? Actually, this is the hypothetical thing. Hypothetical theory is that the carrier of the gravitational force is graviton, which is completely hypothetical, not discovered yet. If it is discovered, then lots of problems will be solved automatically. The next force, and this is the most weakest force, Next force is electromagnetic force. Electromagnetic force are the forces between the charged particle. Force between the charged particles. Like the force between electron and electron, electron and proton, proton and proton, and other any charged particles. It has also range. The range is infinity. So any charged particle which are situated at infinity are connected by electromagnetic force. The intensity of the force will be very less. Okay. The intensity of gravitational force is very less. So someone at Jupiter or Mars, you are also connected through the gravitational force, but we cannot feel it because the intensity of that force is very weak. The third one, which is strongest force, strongest fundamental force, is the strong nuclear force. Now the interesting phenomenon what is there. In case of electromagnetic force and strong nuclear force, they are all deal with the charged particles, but strong nuclear force deal or strong nuclear force holds on what? Inside the nucleus. Inside the nucleus. So inside the nucleus, what we get? Inside the nucleus, we get the proton and neutron. So there are lots of proton, neutron, proton, neutron. Suppose. So we know the neutron is chargeless and proton has the positive charge. So in case of electromagnetic force, two like charges repel each other, and two unlike charges attract each other. But here, neutron is a chargeless particles, and proton has positive charge. So in the base of electromagnetic force, proton must have repulsion, right? But this is not based on electromagnetic force. This is based on strong nuclear force. So inside a nucleus, even though they are same charge, they have the attraction. So that is why it is called a strong force. And though they have these particles, proton, since they have the attraction, so nuclear kept bounded. Nucleus and nucleus kept bounded. They are bounded. So let's imagine inside a nucleus, just imagine inside a nucleus, electromagnetic force, the laws of electromagnetic force is applicable. What I mean? Inside a nucleus, laws of electromagnetic force is applicable. What I mean? This is your task. You have to find out what happens if laws of electromagnetic force is applicable inside a nucleus. Okay. Now the range of the strong force. The range of the strong force is 10 to the power minus 15 meter. That is the dimension of nucleus. Radius of nucleus 10 to the power minus 15 meter. And what is the carrier of the force? Who is the carrier? Who carries this force? One particle, which is elementary particle called gluon. Gluon is the carrier of strong nuclear force. And what is the carrier of electromagnetic force? Charge is the carrier of electromagnetic force. Okay. Now come to the fourth force. This is the weak nuclear force. So this force actually happen in the interaction of elementary particles. This force assigned to the interaction of elementary particles. What are the elementary particles? Electron also elementary particle. Proton is also elementary particle. This gluon is also elementary particle. Some neutrinos, antineutrino, tau neutrino, these are all the elementary particles. Bosons are elementary particles. So interaction among those particles are assigned by the force is the weak nuclear force. And the range is 10 to the power minus 16 meter. Also the carrier, who is the carrier of the force? Carrier of the weak nuclear force. The carrier of the weak nuclear force is the W and plus minus Z boson. So you may difficult to understand what is this. These are the name of elementary particle. Just try to remember, these are the name of elementary particles. W plus minus, that is plus minus means plus Z boson and minus Z boson. So plus minus Z boson. Bosons are the elementary particles. So these are about the fundamental forces. Okay. So there are 4 fundamental forces, and we discuss about the gravitational, electromagnetic, strong and weak nuclear force. Okay. So next in another chapter and next chapters we are going to deal with all the related laws of physics. In class 11 and 12 we are going to discuss almost all the laws, all the phenomena related to physics. So study hard, and this is a very excited subject. Physics is very beautiful and excited subject. And if you have any doubt related to physics, don't hesitate, just ask me. Okay.